streaming. Yo, yo, yo. Okay, what's up, y'all? We're live again. We're live, so it's day 2 of learning, of doing DSA until I'm a master. And we're gonna be right now we're gonna be doing some, or at least doing some bitwise operators and then other stuff too. So yeah, um, actually let's close this for a little bit. Go this. Okay. Okay, let's turn the screen on before I forget. Okay. So yeah. So where's bitwise? Okay. So first let's actually okay, let's just go straight to it. Let's go to this. Maximizing XOR. Okay, I'm gonna have to because I'm gonna have to log in, so I'm gonna have to close this right now. I'm gonna close this right now. Okay. Now we can do this. Okay, maximizing XOR submissions. Okay. Given two integers L and R, find the maximum value of A XOR B written where A and B satisfy the following condition. And then, okay. Action description. Complete the maximizing XOR function in the editor below. It must return uh, an integer representing the maximum value calculated. Maximizing XOR has the following parameters: have an integer lower bound or an integer the upper bound. Input format. Okay. 12. 10 to 15 is with 14, 15. Okay, this is like gonna say the max it ends, and then for I gets L is equal to R I plus plus for int j equals uh there again j is equal to rj plus plus. Say if I XOR j greater than s equal equal I XOR j. Okay, let's see if this submits. Okay, yes. Okay, everything passes. Okay, okay. Okay, so that passes. We're gonna remark this towards the end. Given a set, find two integers a more or less than b from set such that the value of a and b is the maximum possible and also less than a given integer k, maximum possible. In this case, n represents a bitwise end, so it's less than k, so less than k. 2, k, 2, 3. So that's 1 to 5 with k. So print 1. Okay, these are pretty similar. Um, so what do we got? T and we already got T. Where's the main? T, T, T. Okay, we already got T. Okay, let's close this and let's so int math is equal to 0 for int I gets 1i less than equal to and I plus plus. It's actually capital N for int j gets I plus 1 j less than equal to n j plus plus. Actually, from the looks of it, this is less than n, right? This is less than n. Case 2. Okay. So if I and j greater than s and I and j less than k, s equals I and j, then return as compilation error. Oh, this is capital K. Okay. 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 So let's recheck this. Check bit. Rank again. Rank again. What happened? Okay, it's not loading. Not loading. Okay, this one isn't loading. I'll be given a list of 32-bit unsigned integers. Put the first one to 0, all the bits, and return the result as an unsigned integer. Okay, what the heck is this, bro? Okay, yeah, I don't know about this one. Don't know about this one. Don't know about this one. Okay, this one is easy. Just XOR. Just XOR. This is dance for int n in nums. Ans XOR equal n turn ans. And that's basically it. That's basically all there is to it. When I submitted this bro. I've been slacking, bro. December 11th last year. I've been slacking. Y'all call me slacking. Call me slacking and lacking. Okay, what's next? XOR tricks. Single number, missing number. This bit manipulation, we know what it is. While speed bitwise up bitwise. Speed bitwise operations are among the fastest operations a CPU can perform. They happen In a single clock cycle, you can store multiple Boolean flags in a single integer instead of using an array of Booleans. One 32-bit integer can hold 32 flags. Companies like Google, Amazon, and Meta love the manipulation because they test fundamental computer science knowledge. Many problems seem to require all n space can be sorted in one space. Okay, yeah, we good, we good, we good. We good, we good. Okay. Number of 1 bits. Number of 1 bits. Given a positive integer n, write a function that returns the number of set bits in its binary representation, also known as the Hamming weight. Okay, I think this can be done with a mask. Yeah, I'm gonna cheat, bro. I'm gonna look at how to do the mask, the Hamming distance. December 11th, 1 bits. So what we gotta do, dude, we just gotta we can just do count equals 0 while n if n and 1 count plus, and then we can just do this, and then we can return that count. We can do this, count equals 0. Line 14, expected, what, oh, oops, it's outside. We can do this, but I don't know if we can definitely do a mask with this though. Definitely do a mask with this. We can definitely do a mask. Okay, let's look at the bit techniques. Check if a bit is set a bit, clear a bit, toggle, check if power of 2, count set bits. Okay, this is okay, I mean, we just did that, so I'm just gonna do this counting bits. Counting bits. Turn blank binary ends. For each is the number of ones in the binary representation. Hold up, guys. Hashtag Cody. Hashtag DSA. Hashtag Pro. Hashtag Software Development. Just a sec, y'all. Just a sec, y'all. Just a sec. Checking something. Checking something. Okay. Okay, I forgot to put in the comments. Forgot to put tags in the comments. Wait, I gotta bring back the screen. Bring back the screen. Dude, there's like a 10-second delay or something. So for each is a number of ones in the representation of I. Counting bits. Have I solved this? Yeah. Right now, length n plus 1. Such that for each I, and suffice the number was the representation of I. Okay, so basically, so for int I get 0 I less than equal to n, do int j equals I, int count while j if j and the 1 count plus plus j, gonna right shift by 1 and then as push back count and then return as. Okay. Okay, a little slow though. A little slow though. I mean, but it still works. Still works. Reverse bits. Reverse bits. Bro, how have I solved this? Divide and conquer. December 10th. Reverse bits of again 32 bits in signed integer. Okay, I got no clue. I was doing some crazy jumping jacks to solve this. I was doing crazy jumping jacks to solve this. Okay. Okay, maybe let's go to Um, okay. Swap bits. Swap bits. Okay, what's going on? Okay. Reverse bits. We already did that. No. Reverse bits. Okay, that doesn't work either. Okay. Bitwise and what's this frequency? And of numbers range. Into it. That represent the range. Return all numbers in the range inclusive. So is this like straightforward, or is this like, what's the catch for int gets left I equal to right I plus plus? I don't even know if I understand the problem statement. As and equals I turn. Okay, pretty sure I don't get it. Time limit exceeded. Bit manipulation. Present left right. Return the bitwise and of all numbers in this range. Inclusive. Yeah, this is definitely some sort of. This is definitely some sort of trick which I don't know. Hey, we solved 3, so that's something. We solved 3. So yeah. Alright, so I'm gonna go for like 15 more minutes. 15 more minutes. Hash tables. Hash map. Oh yeah. I mean, I'm good with hash maps, so I could solve some of these. Give a string text, you want to use the characters of text to form as many instances of the word balloon as possible. You can use each character in text at most once. Then the maximum number of instances it can be formed. So we're basically just counting. I think we're basically just counting. Um, I think we're just counting. BAL on N. So we're gonna go bool. Oh, I'm just gonna flag to true, and then if not m of b or not, oops, m of b or not m of a or not m of blue. L. Okay, so actually there's an S, which is yeah. Hmm. Hmm. Okay, how do we count this though? How do we count this? To count this. We're gonna do while m b and m of a and m of l and m of balloon o and m of n. So we need two O's to make. If m of o less than o less than 2, break or m of l less than 2. So then we're gonna do m of b minus minus m of a minus minus m of o minus minus m of l minus minus, and then m of n minus minus, and s plus plus. Yeah, I don't actually know if that's gonna work, but okay. Let's see if submits. If it submits, okay. Nope, it doesn't. Does it? Doesn't submit. Does not submit. I think there should be and. No. Okay. Number of good pairs. Given a rate, the number of good pairs is good if okay. I've solved this by how I with a hash map. Damn, January 2024. I've been slacking. I've been slacking, bro. Counting again. Alright, y'all, 5 more minutes and we're gonna end stream. For good pairs. 0, 0, 1, 2, 3, 0, 1, 2, 3, 4, 3, 4, 0, 1, 2, 3, 4, 5, 3, 4. Yeah. Let's go to hash map on this. Let's go to map on this. VJudge, bro. This thing is like. Appointed as the assistant to a teacher has questions creating the answer sheets. Each student can have multiple answer sheets. So the teacher has Q queries and the marks away to the student whose name is. Where's the marks from X? The marks from the student whose name is X. Print the marks from the student whose name is X. If it's again, marks print 0. But Give the number of queries. This queue lines contain one query each. For this integer type of each query. In yeah, is the type of the query. Query is type 1 because it consists of only one insists of one string and integer x and y, where x is the name of the student and y is the marks of the student. Student and y is the marks of the student. If query is of type 3, tutor consists of a single string x, where x is the name of the student. Jesse 20. One Jesse, one Jess. And marks y, the student whose name is x. Okay, so we're gonna add 20 to Jesse. Erase the marks of the student whose name is x. Okay. So we're gonna have n. Okay. So right now it's 6 p.m. So that's gonna be for today. That's gonna be for today, guys. Make sure that you like, comment, and subscribe. And yeah, I'll see you all tomorrow. Have a good one.